Okay, so from an implementation point of view, first step is that we're going to create the context from admin. We're going to tell it what ports that we want to use in the context and what resources we want to use. We're going to switch to the context. Okay, switch to being the specific command there. We say switch to VDC and then whatever its name is. And then assuming that we're logged into the admin context, whatever username we are logged into, that's going to be inherited from the user context. So by default, the root user of NXOS is going to be admin. So if you're logged into admin of the chassis, then it also means that you are admin of the individual contexts. Okay, and we'll talk about the user roles here in a minute, specifically how the inheritance works. Now, in our particular case, if we look at the topology diagram that we are going to be using, okay, so for those of you in the live class there, if you look in the upper right-hand portion of the screen, you should see a PDF that says the physical topology diagram. This is going to be the overall topology of all the racks that we're going to be using. Okay, so racks number 1 through 6 in terms of the rack rentals. Now, when we look at the Nexus 7Ks here in the middle of the topology, all of these boxes in the middle, they are going to be from the combination of one of 2 physical chassis. So there's 2 chassis total. The odd number boxes are belonging to the first physical chassis. Okay, from a hostname point of view, I have this configured as N7K1-admin VDC. Okay, so we'll see this from the CLI when we log into it, that it's talking about the admin context as opposed to the user context. And then likewise, the even number boxes, so 2, 4, 6, 8, 10, 12 here, these are belonging to the second physical box, which is going to be N7K2-admin VDC. But from a configuration in the rest of the control plane in the actual data forwarding, you could have one context that's running a completely separate layer 2 process or layer 3 process, like one is running ISIS, the other is running OSPF, and they're independent processes of each other, or both running OSPF, but they're running separate copies of the protocol. Now, from an implementation point of view, the first thing that we would want to check from the CLI is basically what contexts are already created. Okay, so in this particular case, I'm connected to the admin context, okay, 7K1 admin VDC, and we're going to look at simply the show VDC. Okay, from here it says what contexts are created. Okay, we have the admin context. It says the type is admin. We have some Ethernet context, and then we also have a storage context. So from the 7K's point of view, the SAN switching config and the LAN switching configs are mutually exclusive. Whereas in the case of the Nexus 5K or the 6K, you would be configuring both of them together. You would do your LAN switching for Ethernet, your routing for IPv4, IPv6, plus your fiber channel or your fiber channel Ethernet. You do that all in global config. Where in the case of the Nexus 7K, you have to dedicate one virtual context just for storage, and then the rest of them are for Ethernet switching at layer 2, and then IPv4, IPv6 routing at layer 3. Okay, what this also tells us here is what are the line cards that are allowed to be in the context. So if we look at here over on the right here, it says LC for the line cards. It says there's no line cards that are assigned to the admin VDC. Okay, the reason why is that the admin VDC, the only thing it's doing is managing the chassis. So I'm telnetted in to the admin VDC right now, or you can SSH into it. Then from there, I can control what these other contexts are, what are the interfaces, what are the VLAN resources, etc., that are going to be assigned to them. But a key point here is that there are limitations on how these line cards are going to be allocated. So it says globally, the switch mode, the switch-wide mode is that you can run whatever card you want. Okay, generation 1, generation 2, generation 3. But then inside the individual context, there's limitations. So I could not take an M1 card and put it in context N7K5 because this has F3 cards allocated to it. Okay, so these are mutually exclusive based on that module comparison matrix. Okay, so in this case, we're going to create a new context. So we're going to go to global config. So first off, let me enable logging. We'll say terminal monitor. We're going to go to global config. We're going to say VDC, and we're going to give it a name. Okay, in this case, the VDC is going to be called N7K1. Okay, the name itself is arbitrary. You can change this afterwards. It's just the host name of the box. You'll see what is going to be unique, though, is going to be the identifier, basically the number of the context when you go to create it. And this will be part of the running config. So you don't need to specify this number, but just the order that you create it. The admin context is going to be number 1, and then the rest of them are going to count up from there. Okay, so previously context number 2 was there, and I had deleted it. I'm now recreating it, and in this case, I'm calling it N7K1. Okay, the goal of this exercise here is that we are going to make the network look like this from the physical chassis point of view. So we're creating context N7K1. We're going to take line card number 1, okay, which from a naming point of view is going to be these Ethernet 1/something ports, okay, E1/X. And we're going to assign ports 1, 2, 3, 4, 5, and 6 to this individual context. Okay, so once we create the context, it's going to take a minute here for it to actually start. Okay, you can see it says VDC Manager says VDC2 is online. And if we look at now the show VDC, it says we now have context number 2. Okay, that's its identifier. Its name is N7K1. Okay, once we create it, the next step is that we're going to switch to it. Okay, so we went into the global config of the admin context. We create the context, and then we're going to switch to it. Okay, a couple other commands here that are useful. One of them is going to be the, go back to the slide here, which is going to be the no VDC combined host name. This means that by default, when you look at the prompt of the switch, it's going to have the admin context name followed by the user context. So if I was calling this switch N7K1, the host name from the CLI point of view would be N7K1-admin-VDC and then the user context name. So it would be -N7K1. But from like a managed service point of view, if you don't want the customer to know what physical box that they're part of, you can turn this off. Okay, so but the default behavior is that this is on, VDC combined host name. Okay, also the contexts are going to get unique MAC addresses. We'll see this from a layer 2 switching point of view. Once we start to configure spanning tree, we're going to need a unique MAC address in order to generate our spanning tree bridge identifier. But we'll see that when we look at the multiple root bridges, a lot of the contexts are going to have very similar MAC addresses because they come from the same pool that's based on the supervisor. And from the CLI, we can see this if you say show SPROM backplane for line card number 1. Okay, well, line card number 1 is going to be the supervisor. Okay, so we can see it says that the product number, in this case, it's 7010, which is a 10-slot chassis, okay, generation 1. And then it should tell us also what is somewhere in here, what is the MAC address, base MAC address, and then what is the block of addresses. We have 128. So essentially anything that is coming from this physical box, where this physical box being the host name N7K1 admin VDC, the MAC addresses are going to start with this number here and then go up to 128 addresses after that. Okay, so you don't need to configure this separately. Like in the case of the ASA, sometimes when you have overlapping interfaces, you need to manually change the MAC address so it's a unique value. In the case of Nexus 7K, it's automatically going to pick a unique number from this, this pool of addresses.